Let's talk about where these formulas come from. This one's the easiest one, right? This is our final velocity, and this is our initial. How do you spell initial? There we go. Okay, there's our final. This is our initial velocity, right? Is our u. And then AT is just the change in velocity because acceleration is change in velocity over time, right? So really that formula right there is just saying that the final velocity is the initial velocity plus the change in velocity. This is true about everything. Everything is, the final everything is what it started out plus the change. Like for example, the price of a stock is its opening value plus what it changed, right, during the day. So that's what that is. That's just initial plus the change. AT is the change, okay? Now this guy right here, if you look at that, this is initial and final velocity. This assumes a constant acceleration. So all of these things work only if it's a constant acceleration, okay? If it's a constant acceleration, then really displacement is just average velocity times time. We can't argue with that, right? That's sort of the definition of average velocity, right? Do you see that if you add two numbers together and divide by 2, you've taken the average of them, right? So literally that's what we're doing, and it works only if there's a constant acceleration, okay? So that's where those come from, and then the other two formulas, or even 3 if we wanted to derive them, come from these formulas. And let me show you how that works, okay? So the first one is, and we always start with, I think, this equation. S is u plus v over 2 times t, right? So we start with that. Right, and then I'm just going to substitute, instead of v, I'm going to substitute the u plus at in there, right? So then we get that equals u plus at, right? And that's over 2, and then that's times t, right? And then we just multiply across, and we end up with 2ut plus, I'm just multiplying the t across the top, plus at squared divided by 2. And then, of course, the s then equals ut, because this term here, the 2's cancel out, right? Plus 1/2 at squared. So there's that formula that we so affectionately call what? No final velocity, no v, right? That's no v, right? And then let me show you how to get the other one, right? I'm going to show you how to get no t. I think what I'll do is I'll take this formula and solve it for t, right? So t is going to be, if I solve this for t, it's going to be, what is it, v minus u, and then that's divided by a. Okay, so v minus u over a is t. Okay, so I'm going to substitute that in for t. So I'm going to use the same formula. S is u plus v over 2 times t, and then I'm going to substitute v minus, that's a u, not an a. So v minus u over a, right, for that. So I'm going to go u plus v over 2 times v minus u over a. Okay, and then let's see, the denominator is clearly 2a, right? And then in the numerator, we have to FOIL this, right? So uv, right? And then we're going to go minus vu, right? And then we go minus u squared plus v squared, right? So notice that the u times v and the v times negative u, those terms cancel out. We end up with this, right? And then if we rearrange this, we end up with v squared is u squared plus 2as. Right? So that's where that formula comes from. It just comes from substituting this, parts of this, into this. Okay? Now notice that there is no formula for no u. We don't derive it. But if you wanted to derive it, all you'd have to do is solve for what u is, right? U is, what is it? It's v minus at. Is that right? And substitute that in for u. And you could have a formula that's just all v. You could go ahead and derive it. It looks a lot like this, only it's vt, and that's not a plus, that's a minus. Okay? I'm just saying you could derive that. Okay, so that's where those formulas come from. I just thought I'd post a video about that. I used to do that in class, but I don't do that anymore.